Hi everybody, here is the reading assignment for week 3, and I am Li Manqi. First, I want to summarize the main physics ideas. They are acceleration, the gravitational force, and the electrical force. And then I want to talk about the physics idea that I know. The first one is the definition of acceleration. It is equal to the final velocity minus the initial velocity divided by the change of time. In other words, acceleration is the rate of change of velocity. And the second one is the gravitational force. It is equal to the universal gravitational constant times the mass of the system and the mass of the source divided by the distance between the system and the source to the power of 2. And the third one is the electrical force. It is equal to 1 over 4 pi epsilon 0 times the charge of one particle and the charge of the second particle divided by the distance between these two particles to the power of 2. Notice that I used the magnitude format here because I only learned about magnitude format back in my high school. And then I want to discuss the physics ideas that I did not know. The first one is something about the gravitational force. Look at the first formula. Here we have the unit vector here. It represents the direction. That is something that is unfamiliar to me. And here is the second formula. We need to use the position vector of the system minus the position vector of the source to calculate the vector r here. And then these two images show me how to derive this negative sign before the unit vector. We can notice that the vector r is from the source m1 to the system m2, and the gravitational force on m2 is directed toward the source. So the vector r is in the opposite direction compared with the gravitational force. Therefore, there is a negative sign before the unit vector. And then I want to talk about how to calculate the magnitude of a wave force near the Earth surface. Previously, I know about the formula, weight is equal to mass times small g. However, I don't know how to derive this small g, which is the gravitational field strength. And here we use the formula of gravitational force to derive that. ME is the mass of the Earth, M is the mass of the object, R is the radius of the Earth, and Y is the distance between the object and the Earth's surface. Because the object is near the Earth's surface, we just ignore this Y. And here we have this formula, rearrange that, we derive a constant here, and that constant is the small g. And then is the electrical force. Also, this unit vector here is unfamiliar to me, and also the sign of this unit vector is determined by the sign of the product of charge 1 and charge 2. If both charges are negative or positive, then the sign of it is positive. If one is negative and one is positive, then the sign is negative. And then I want to talk about something that sparked my curiosity. I'm curious about why are the formulas of gravitational force and electrical force so similar? Is that because they are both forces, or are there any other reason? And this week's lecture is related to my major, computer science. We did programming to do calculus in physics. We take delta t really small and do a while loop to input the velocity and output the final velocity. The only difference is that in computer program, we cannot take the delta t infinitely small. And I think that is the one difference between the real calculus and the computer program. And then I want to talk about something confusing or difficult for me. I don't know why the unit vector represents the direction. And then I Googled and I found an image on Wikipedia. It shows a unit vector here, and it has a length 1. So a formula times the unit vector will not change the magnitude of it. However, it will add a direction like that, a line through the origin and the coordinate 0.707 and 0.707. This is how the unit vector represents the direction. And thank you for listening.